What is up, nerds? The Immortal Nerd here, and welcome. Welcome. First, let me say welcome back to my channel. I know it's been forever since I've uploaded something, but I decided to, make something. To put it in simpler terms, um, I got this drive to record. I've always had this idea, but the drive wasn't there. But the drive is here now, and hopefully it becomes of something, and I hope it makes this channel grow. So what I am doing, let me explain this. I am starting from not necessarily square one, but I will be using my expertise, which is me being a math and physics tutor. I'm using my expertise to help those that are, that always struggle in math or don't like math and would need a easier or better understanding to, help them with certain problems. So starting off with this video, I will be doing pre-calculus problems all the way from chapter 1 to, wherever any chapters that is dealt with mainly in a pre-calculus course that you would take at any college. So I am using a particular book. It was one that was used at a community college that I worked at. If you want to find it or follow along, it is the Pre-Calculus Functions and Graphs 4th edition book by Dugopolsky. You'll know it's the right one. The book is red and it has like the front end of a motorcycle wheel up front. So yeah, that's the book I'll be using for this video. And we're going to get started in, the first chapter. Now, what I'll be doing, I won't be going in each section and explaining what they're talking about. We're just going to go straight in to the chapter test, because at the end of each chapter they have, the highlights, the review exercises, and then the test. We're going to go straight into the test, and whatever problems we run into, I'll go and explain how we solve those problems. So with that being said, we're going to go ahead and get right into it. Chapter 1 test. So in this first bit of this chapter 1 test, we are talking about finding all real or imaginary solutions in equations. So I'm going to pick out, I'm gonna do 4 of them. So this will be one video in itself, and then in the next video, it will be another part of the test that we're doing. So this first video, finding all real or imaginary solutions. So I think 4 problems is enough for this kind of video. So the first one we're gonna do, we're gonna go ahead and get it out the way. It's gonna be dealing with fractions. So first equation, we have 1/2 x minus 1/6 equals, I know my 6 is looking kind of funky, equals 1/3 x. All right, I said we're gonna go ahead and get this one out the way because fractions is something people do not like, especially those that, don't like math to begin with. Fractions is either fractions or decimals or both. So we're going to go ahead and get this one out the way. Now, when you're solving this type of equation here, it's a linear type of equation. And the reason why I know it's a linear type of equation is because if we're looking at the variables, in this case, the x's, we notice that there is not an exponent. The exponent there is isn't greater than 1, I should say. So that's one way we know that it is a linear type of equation, the exponent is understood to be a 1. So that's why you don't see the number 1 there, because it's understood. So we know this is a linear type of equation, so we should only have one solution when we solve this equation. So now, in order to solve it, the first thing we're going to do is get rid of these fractions. That would be the simplest way to do so for people who don't like fractions, and, to make it a lot easier to solve. Now, me, it doesn't really matter, or anybody who, understand numbers and the concept of it all. It doesn't really matter what you do to it. They can leave it as a fraction to solve for it. But to, beginners, it's easier to put it in a form that you're used to seeing when you're solving equations, and then, work it out from there. So getting rid of the fractions. So how would I do that? How would I get rid of these 3 fractions that I see here in this equation? Well, that will be by multiplying the entire equation by a common denominator, or I should say a common factor, or even more, to be more specific, a multiple of the denominators. So the 2, 6, and the 3. I want to multiply this entire equation by a common multiple of those 3 denominators. It doesn't really matter which one it is, but it is preferred to be the least one, so that way I don't have to simplify as much towards the end. So with these 3 numbers, it should be pretty simple to figure out what the least common multiple should be for the 2, 3, and the 6, and it will be a 6. So I am going to multiply this entire equation by a 6. So the 6 is going to be multiplied to the 1/2 x. It's going to be multiplied to the 1/6. And it's going to be multiplied to the 1/3 x. So 6 times 1/2 is 3. So I have 3x minus 6 times the 1/6, that is a 1, equals 6 times the 1/3 x, which is a 2x. All right, so this is looking a whole lot better now. No fractions. We got pretty little whole numbers to deal with. So piece of cake. So now we can proceed with the steps that we learned to solve linear equations. Get all the variables on one side and the numbers on the other, and then do what we need to do to get the variable by itself to solve the equation. Now, I'm not very particular on which side the variable needs to be on. It's all about how much work do I want to put into it, essentially. So in this case, I am going to have, well, in this case, it doesn't really matter. It's going to be the same amount of work. So I already have my number, the -1, on the left side. So I'm just going to move the 3x over to the right side of my equation. So in order to do that, I need to do the opposite. I need to do the opposite operation of what it is already. So the operation that it is on the left side is a positive 3x, or plus 3x. So in order to move it to the opposite side of the equation, I got to do its opposite sign, or opposite operation. So the opposite of positive or plus 3x is minus 3x. So I need to minus 3x on both sides of the equation. And the reason why we're doing it on both sides of the equation is because it's an equation. Things has to stay equal. It has to stay balanced. So whatever you do on one side, you got to do it to the other. So in doing so, 3x is no longer on the left side, because the 3x minus 3x gives you 0. So we're just left with the -1 on the left side of the equation, equals 2x minus 3x, which is a negative x. So now the next thing I'll do is divide or multiply by a negative 1 to get. So negative 1 divided by negative 1 is a positive 1 equals x. So there you have it. You have your solution, x equals 1. And to check to see if it is correct, you can take that solution, x equals 1, and plug it back in to the original equation to see if the statement, holds together. If it does, that means we did it right. If it doesn't, that means we made a mistake somewhere. So we have to go back and see what that mistake is. So I'll leave that to you guys, and we're going to move on to the next problem. All right, so we have a new problem here. X squared plus 1 equals 6x. So this one is a little bit different than the last one because this one is a quadratic equation. And the reason why I know it's a quadratic equation is if I'm looking at the variable, one of the variable, x, it has an exponent 2 up there. And that is the highest exponent in this equation. So the other one is the understood 1 on the coefficient 6. So that lets me know this is a quadratic type of equation. So knowing that in mind, I will use any of the methods that was taught to us, or given to us, I should say, to solve these type of equations. So when solving quadratic equations, you have, you can do it by, graphing it. You can do it by factoring. You can do it by completing a square, quadratic formula. We're going to do it by factoring. We're going to see if that works first. And then if not, we'll use the quadratic formula. And yeah, so we'll either do it by factoring or using the quadratic formula. There'll be no need for us to use a completing a square unless I run into a section that says specifically to use completing a square to solve the equation. But first, we're going to see if we can do it by factoring. So in order to do that, I need this quadratic equation to be in its standard form, which is, I'm going to write to the above here in red, ax squared plus bx plus c equals 0. I need it in this form if I'm going to solve it by factoring, and if I'm going to solve it by using the quadratic formula, because I need to know exactly what is the coefficient a, b, and c. So essentially, my quadratic equation needs to be equal to 0, no matter if I move everything to the left side of the equation or to the right side of the equation. So in this particular case, I'm going to move everything over to the left side of the equation, only because that's less work for me to do. I only have to move one term instead of the 2 terms to the right side. So if I'm going to move the 6x over to the left side of the equation, it's already a positive 6x. So in order to move it over, I need to minus 6x on both sides of the equation. It doesn't really matter where you put the 6x underneath because it can't combine with anything on the left side of the equation because there aren't any alike or common terms with it. There's only an x squared and a 1. So there is no other x term there, so it can't be combined. So when I go to write down what's on the left side of my equation, it is the x squared minus 6x plus 1 equals 0. So now that I have it in its standard form, ax squared plus bx plus c equals 0, I'm going to solve this by factoring. So I'm going to use I don't know what's the term for it. I think it's the perfect square trinomial, if I'm not mistaken. if it's a perfect square trinomial, you can use this method where you have to find two numbers that will multiply to give you the constant, and those same two numbers have to add up to give you the minus 6. So if we're looking at it, the only two numbers that will multiply to give you a positive 1 is a positive 1 and a positive 1. And those two numbers cannot give me a negative, let alone a negative 6. So right off the bat, I know it can't be factored. So if we were asked the question, is this equation factorable, we would say no. But we're looking to solve it. So it's not factorable. So we need to move on to use the quadratic formula. And the quadratic formula is our negative b plus or minus the square root of b squared minus 4 multiplied by the a and the c. And all of that is divided by the 2 multiplied by the a. So this quadratic formula will give you two solutions of the variable that we're solving in. So we know what a, b, and c are. A is the understood 1, b is the negative 6, and the c is the plus 1. So we just plug it into the formula and make sure our arithmetic and computation is correct when we solve. So x equals negative. So the negative that's in the formula, that is already there. So we need to put that negative and then input the negative 6 for the b plus or minus square root of the b squared. So again, plug in what the b is, squared, minus the 4 multiplied by the a and the c. So the 1 and the 1. So all of that is underneath the square root. Make sure you remember that. And all of this is divided by the 2 multiplied by the a, which was a 1. All right, so now to simplify and evaluate. Okay, so the negative b portion, the negative of a negative 6 is a positive 6 plus or minus the square root of, so I have the negative 6 being squared, so that's 36, minus the 4 times 1, which is just 4. All of this is divided by 2. 2 times 1 is 2. All right, so next, I will move over to the right. 6 plus or minus. So 36 minus 4 gives us what? 32. All of this divided by 2. So now the next piece is to simplify the radical. So now the 32, that is not a perfect square. So it's not going to come out as a pretty whole number. So we have to simplify our radical there. So in order to do that, we are going to do it the simpler way. We're going to do a complete factorization of 32. If you know another way to do it, by all means, go ahead and do it that way. Okay, but if you're following the way that I'm doing it, so I did a complete factorization of the 32. So that's 2 times 2 times 2 times 2. times another 2, because 2 times 2 does not give me 8, it gives me 4. 2 and that 2. There we go. So complete factorization of 32 is 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5 2's. That's better. All right, so now what I'm looking for are numbers in groups of 2's. And the reason why I'm looking for numbers in groups of 2's is because of the radical that is underneath. It is underneath a square root. So a square in terms of exponents is a 2. So we need to look for numbers that can come in groups of 2's. And we have that. The number 2's can come in groups of 2's twice. We'll use a different color here. We have this pair. And we have this pair. So those 2's will come out as a 2. 6 plus or minus 2. So that would be for the first pair. Times the other pair, 2. And what's left inside is the 2 that wasn't paired up. All right, so now here, we can go ahead and multiply the 2 and the 2 to get the 4 if we want, but the reason why I didn't do so is because more simplification. If I look at the denominator, that is a 2. And that can be divided into the 6 and one of those 2's. So in doing so, I will have x is equal to 3 plus or minus 2 square root 2. So these are my two solutions. X is equal to 3 plus 2 square root of 2 and 3 minus square root of 2. 2 square root of 2, excuse me. So again, when you have a solution, you go back and plug, in this case, each of these in separately to see if they are correct into the original equation. So again, I'm not going to do that. I'll leave that to you guys to do. And we are going to move on to the next one. All right, so I found this to be much easier. I can just copy the image from the book and put it on my whiteboard here. So that way I don't have to write it out. And you guys won't have to deal with my handwriting as much. So this one here, we have what's called rational expressions on each side of the equation, and we need to solve this equation. So again, fractions. So don't be alarmed. Simple way to get rid of these rational expressions to make it in a form that we're used to seeing. So in this case, we won't be doing what we did in the last one by multiplying the entire equation by the least common multiple. Not in that sense anyway. What we'll do here is something different. What we'll do is called a cross multiplication. So not across, like directly across horizontally, but diagonally cross. So I believe the reason why it's called cross multiplication is because I'm sure you guys know how to do it. Is it makes a cross when you do so. So you can only do this when you have two fractions on separate side of the equation, and it's only one expression on each side of the equation. If I had the x minus 1 over x plus 3 and then a minus 2x on the left side of the equation, then I wouldn't be able to do this. So it has to be singular expressions on opposite sides of the equation in order for me to implement the cross multiplication. So this is how I will be getting rid of these fractions, if you will. So the x minus 1 multiplied by the x minus 6 equals the x plus 2 multiplied by the x plus 3. All right, so as you can see here, we have binomials being multiplied to each other on opposite sides of this equation. So what do we do when we have two binomials multiply together? We multiply them, or the more familiar term, we FOIL them out. So we're gonna do that to both of these binomials on the left and right side of this equation. So starting with the left side, the x minus 1 multiplied by the x minus 6. Well, let's do it in a different color. That. That. This. With this. You'll get x squared minus 6x minus x plus 6 equals, and I'll do the combining when I finish. So same thing here. You get x squared plus 3x plus 2x plus 6. So now combining like terms with common terms. So that would be the two innermost terms, the x's. So the minus 6 and minus x, and the minus 6x and the minus x, and the plus 3x and plus 2x. I got to be very specific when I'm talking about math here. So now when I combine, on the left side of my equation, I have x squared minus 7x plus 6 equals, on the right, x squared plus 5x plus 6. All right, so now I'm going to move all of my variables on one side of the equation and just my numbers, aka my constants, on the other side. So I'm going to move all my variables to the left side and then all my constant numbers to the right side, just because. So minus x squared minus x squared minus 5x minus 5x and it just so happens these x squares cancel out as well. And this over here, a negative 7x minus a 5x, that would give me a minus or negative 12x. And now I'm going to minus 6 over. And we see those completely cancel each other out. So I have a 0 on the right side of my equation. So now when I go to solve this equation to get rid of that negative 12 from the x, I'm going to divide both sides by the negative 12 to get x is equal to 0. And that is your solution there. Again, if you want to check, you take that solution and plug it back in to the original equation to see that it satisfies that statement. And if it does, we did a good job. If it doesn't, got to go back and see where we made the mistake. So that will do it for this video, you guys. This will be the last. This is the last problem that we did here. And for the next video, we will be doing sketching the graph of each equation in a XY coordinate system. So that's also another thing some people have difficulties with, is reading graphs, or making a graph. Yeah, so that would be for the next video. I hope you guys did enjoy this video. If you did, hit that thumbs up button. I greatly appreciate it. And also subscribe. Again, like I said, I do want this channel to start to grow more. Like my other channel that I have, my more personal fun one, because I also, besides doing math and physics, I like to watch anime. I like anime. So if you also want to come over there and subscribe to that, you can. But if not, that's cool. You can stick around here and subscribe to my math and physics channel. Feelings won't be hurt. But with that being said, again, I hope you guys enjoyed it. If you did, like, share, subscribe, get this out there to all the nerds in the universe, multiverse, and alternate dimensions. And I will see you in the next one. The Immortal Nerd, signing off.